Hi, I'm Tom English, and today's lesson is on probabilities. But when we talk about probabilities, we also have to talk about possibilities, and we need to understand the difference in the two. When we talk about possibilities, we're talking about how many times or how many different ways can an event occur. Let's use an example of, let's say we're getting dressed for school in the morning, and let's just look at the fact that we maybe have 3 pairs of shorts and we have maybe 4 t-shirts. And the question is, how many different combinations of shorts and t-shirts can we get with that? One way of looking at it, we could graph it in what I call a tree of possibilities. And if we think about it, we say we've got red shorts, and we have tan shorts, and we have black shorts. Okay? Now with each of these, we could wear one of 4 different shirts, can't we? So one way of representing that, let's say we've got t-shirt 1, t-shirt 2, t-shirt 3, and t-shirt 4. So with that first pair of shorts, we've got 4 possible combinations, don't we? Well, I hope you can see it's the same for each of the other pairs of shorts. 2, T3, T4. And again, I hope that what you see is we've got a total number of possibilities of the product of these two. In other words, 3 shorts, 4 times 4 shirts equal a total possibles of 12 combinations. Okay, and I hope you can see it gets more possibilities if, let's say, we've got a couple different pairs of shoes. Maybe we've got tennis shoes and sandals. So that adds 2 more to this combination. So that would be what? 2 times 12. So that takes it up to 24 possibilities. Okay? Now if we looked at what's the probability of, let's say, wearing sandals with the black shorts and the first t-shirt, well, there's only one possibility out of that, isn't it? So we'd say the probability of wearing the sandals, the black shorts, and the first t-shirt would be 1 out of a total of 24. So that's how we express the probability of that particular combination. Okay, it's a little more difficult with shirts. Let's go to the proverbial bag of marbles. I think everybody's had these kinds of problems. And let's say, in my example here, we have 3 red marbles, 6 white marbles, and 9 blue marbles for a total of 18 marbles. Now when we talk about the probability of selecting a red marble, just reaching in the bag, they're all mixed up, we pull out 1 marble. The probability of it being a red marble would be the number of red marbles, which is 3, over the total number of marbles in there, which would be 18. So we'd say the probability, we can reduce that fraction to 1 over 6. So the probability of pulling out a red marble would be 1/6. The probability of pulling out a white marble, well, we've got more white marbles in there, don't we? So we've got 6 white marbles out of a total marble population of 18, and that probability then would be 1/3. And finally, the probability of pulling out a blue marble, well, there's 9 of them in there, still out of a total of 18. 9 over 18 is 1/2, isn't it? Now, if we said, what's the probability of pulling out a red or a white or a blue? Well, those are our only chances, aren't they? So if we add those up, that's 18 over 18. So that is equal to the probability of 1. 1.0, 1 over 1, 1. They call that certainty. The problem is, you're reaching into a bag of red, white, and blue marbles. The possibility of pulling out anything other than that is nil, isn't it? So this is called certainty. So if we add the individual probabilities, hopefully they're going to add up to 1, because that's what certainty would be. Well, we added these fractions, common denominator is 6, so we convert each to 6, and we now have 1 plus 2 is 3 plus 3, 6, 6. Is that equal to 1? It is. So think about that if you're doing a problem like this, and you know you should total up to 1, use that again as a double check on that. Let's throw some others though. Each of these, if we're pulling out a marble, that is considered one event, okay? And that is independent of anything else, right? However, if we're pulling out 2 marbles, then that's called a compound event. There's more than one happening. And the question then is whether the second one is independent of the first or not. Well, to be independent, it has to have the same number of marbles. So we talk about with replacement or without replacement. If we pulled out, for instance, a red marble, the probability of that, as we showed, is 3 out of 18. But if we said, what's the possibility or the probability of pulling out 2 red marbles, the question you have to ask yourself, are they dependent or independent? In other words, am I going to replace that first marble before I draw the second? Now, if I replaced it, then the probability of the first one being a red one is 3 out of 18. The probability for the second one, as long as I replaced it, we still got 18 marbles in there, and we still got 18 in total, don't we? So they're independent because we replaced it. What if we didn't replace it though? We drew 1 out, a red, and then we reached it back in again. How many reds are in there at that time? Well, in that case, we've only got 2 reds, don't we? And what's our total? It's not 18 anymore, it's 17 because we left that one out. So, can you see where the probability of pulling out 2 red marbles is going to be dramatically different if you replace it or you don't replace it? Let's figure those. With replacement, then we have 3/18 times 3/18, which we reduce both of those 1/6. We end up with 1 over 36. We divide 36 into 1, and I think we get about 2.8%. Okay, another way of expressing probabilities is percentages. We just convert the fraction to a percentage. Now, without replacement, you think it's going to be higher or lower? Well, the key here is 2/17 greater than 3/18 or less than 3/18? Let's see if we'd have 3/18 for the first one times 2/17 for the second one. Again, this is 1/6. We've got then 2 over 42, 102. We reduce that down to 1 over 51. And I hope you can see that that's just a little over 2%. So it's, let's call it 2.1%. Okay? Without replacement, that goes down fairly significantly. Because we've got, first of all, we've got less red ones, and we've got less marbles altogether. Let's take a couple other examples. Let's calculate the probability of pulling out first a red one and then a white one. Okay? Again, with and without replacement. The red one we said is 3/18 is 1/6. What's the white one now? There's still 6 in there, isn't there? But there's not 18 marbles, there's 17 marbles. Now, to get the probability of this compound event, the two happening and coming up with the desired sequence of red and then a white one, we just multiply those two individual probabilities. So we have 1/6 times 6/17. The 6's cancel, we get 1/17. Who's got their calculator? 17 goes into 1, goes into 100, almost 6, right? 6 times 7 is 42, 6 and 4 is 10, so it's just barely under 6, 0.06, which is 6%. Now, what if we didn't? This is without replacement. What if we did replace it? Okay, then we still have 1/6 for the first one, but how does the second one change? The second one now, we still have 6, but instead of 17 marbles, we've got 18 marbles. So this is 6 out of 18. Well, it makes it a little easier because that's 1/3, right? So now we have 1/6 times 1/3, which is equal to 1 out of 18. Okay, notice the change. It went from 1 of 17 to 1 of 18. Is this higher or lower as a percentage? Well, we're dividing by a bigger number, so it's going to be a smaller percentage. 18 goes into 1, let's see. If we go 5, that's 40, that's 90. So it's a repeating decimal, so this is about, where this is almost 6%, this is about 5.5%. So I hope you can see that the difference with replacing or not replacing is very significant. And also recognize the compound event is more than one, and if it's independent, says it's been replaced. We replaced it. If it is dependent, then we say we did not replace. Okay, so understand those terminologies. Okay? Probability's not that difficult, but make sure that you first understand that the total possibilities is the denominator. The individual possibility for the particular event that you're looking for, whether it be red or blue or white, is the numerator. Thank you much.